All right, let's go on and talk about the actual work in class. So stacks and queues. Did y'all do stacks or queues in OOP?
I think like that one.
That much? All right. So we're going to talk about stacks and queues. These are going to be your first abstract data type. So beforehand with arrays and linked lists, I would call it more of a concrete one. They don't give it a term, but I call it concrete because that's how the actual data is stored in the machine. In other words, the array and the linked list say that you have to store the data a certain way. With the abstract data type, we just define an interface, and you have to implement the interface, which however you want. You can implement it with an array, you can implement it with a linked list. But since it's abstract, we just define the top level interface, and then your job to make it happen, Captain. Hey look, objectives. So stacks, the data structures in which elements are added and removed only at one end only. This is called the LIFO, the last in, first out. All right, let's draw a picture, and hopefully everyone will get this. I'm going to draw a stack from the bottom up, because I think it makes more sense to me. Actually, I lied. We're going to go top down, because that's how we've been drawing it this entire time. So there, last second change. All right, give me a number.
15.
We have 4, 15, 1,
-3.
-3. Okay. So we have push 4, push 15, push 1, push -3. All right. Then we're going to call pop, and that's going to return -3. And then we're going to have top right here will then point to this guy. All right, give me another number. Push
12.
12. Put a 12 right here. No. All right, let's push another number. 7. All right, and then pop will give us 7. And then pop next time would give us 17. Actually, that's a 12.
That's, oh, that's a 12?
That's totally a 12. See? How about now? It's a 12 now. And we pop again, what are we getting? 1. Now you notice I'm not clearing the numbers. Let's go push again. You want to push? 9. We're going to push 9.
Never puts 1.
And then I heard a 52. Okay, and if I were to pop at this point, I'd get 52. And then if I popped again, 9. All right. So basically, you're pushing and popping on the end. It's like a stack of plates, except for you can only put one plate on at a time, and the plate has a number on it.
And they're out of order.
Yeah, we don't care about order right now. You don't sort stacks. Well, you can, but don't do that. All right. How's everyone doing? That's the stack. Everyone got that? All right, great. Let's see what else I have to tell you about stacks. Hey, look, it's a stack of stuff, stack of boxes, stack of coins, stack of trays. Empty stack is on over here. Pushing A, B, C, D, E, and then peek. Oh, so you can peek at it. So peek looks at the top one but doesn't return it, and then you can push it and then pop the stack to take it off. Great.
Wait, it doesn't return it? So what's the point?
I'm sorry, what's that?
It doesn't return it? Like tell you what's at that point?
Technically, no. So I've been cheating here. I've been trying to make it easy for you that pop is going to return it, In C++, well, I'm sorry, in Java, pop returned the top object. In C++, it does not. You have to call peek in order to see it. Hey, look, there's the ADT. Okay, hold on. So how should we implement a stack? Well, we have 2 data structures so far, right? Which one should we use?
A linked list.
Why do you say we should use a linked list?
Because we have not done as much with it.
Just to see.
Just so we can get more exposure.
Okay. So we want to get more exposure. Okay, that's a good reason. But what if you knew everything there was about arrays and linked lists? Which one would you choose for a stack?
Linked list.
Why?
Because if you have to add something to the stack and
It's
you don't have
dynamic.
the data. Yeah.
Then you have to reallocate it. But with a linked list, you just keep adding. Right. So in general, doing this with a linked list is going to make way more sense. But you can do it with a stack. With an array. The problem with doing it with an array, of course, is that once you fill up the stack, you have to reallocate a new array, copy everything over, and then, yeah.
Which isn't great.
No one wants to do that. So we talked about it with arrays. That's nice, that's nice, that's nice. Oh, look, they're going to do it the other way. Okay.
Well, technically the stack can only be so big, right?
We haven't talked about a size and putting a size on the stack or limiting its size. You can keep adding. Who says the stack of plates can't just keep going on all the way to the moon or Mars? Or Pluto? Oh wait, Pluto's not a planet anymore. Poor Pluto.
Just a space rock.
I know. It's okay, Pluto. I'm not a planet either.
That'd be a problem.
It would be a problem.
I thought it was a dwarf planet.
I think it is a dwarf planet now.
If you were a planet, would you have your own like satellites and everything?
Basically, they're calling Pluto a midget, is what they're doing.
Yeah, that's really, yeah. Because they found other midgets. And they didn't want to add them, as planets. Wait a minute. I don't think this conversation's going the right way.
For some reason, I thought of General Grievous, but he's holding Pluto.
General Grievous, oh yeah.
Yeah, this planet's like.
Oh yeah, there we go. That's a good question. Now you got me on that one. So, which set of Star Wars movies did y'all watch first? The prequels or the regular?
Number order.
I saw the prequel.
4, 5, 6. Prequels.
Number order.
Numbered order, so you saw the prequels and then the original? How was that? I'm curious.
It took away from the big Darth Vader is Anakin reveal.
Oh yeah,
And
yeah, it probably did
it
totally
took away
kill.
from the Lucas Padme's brother.
Yeah, I have a feeling. Yeah, I believe that. Yeah, I do believe that it probably took something away by doing it in that order. That's
Yeah.
true.
Made it a little weirder in that case.
But anyone who saw the originals and then the prequels, did they not like the prequels? Thought they were okay. What's that?
I didn't like it.
You didn't like them? But watching the prequels first, did you like them and then you liked the original? Or did?
I like them all.
Yeah, I like them all.
Sometimes
I think that's
fall
what-
asleep like for 5 minutes, but that's fine.
I realized that the prequels are kind of garbage, but I still like it.
You like? Okay, interesting. Well, nice tangent, guys. Just curious. Notice I have not mentioned other things. All right.
Yeah.
Whew. All right, so we could do it with arrays. All right, you know what? And you could type this all out. Okay, guys. We are now gonna make your life easier. Or I'm gonna try to. But don't yell at me. So, okay, you know what? You may yell at me. That's perfectly fine. I'm okay with that. May I load a? There we go. So hopefully in Java you had your array list and your linked list, which implemented an array and a linked list. So C++ has the same thing. It's called list. got to go to this site. It always takes longer to load. Oh, that was pretty fast. So std list, and it's templated on what type you want to template on, and then you can call what type of allocator you wish. For this class, whenever you see allocator, ignore it. We are not going to use it. But what the allocator is in case you're using your own, by the way, bless you, your own memory management routines, you can overload what the STL uses to allocate the memory for itself with your own allocator. But we don't care about that because we're not doing that type of programming in this class. So you can just ignore that and accept the default. By the way, when you have a template and then an equal afterwards, whatever it's equal to is the template, and then you don't have to specify it, which is great. Yes?
Are we going to use allocator in our other classes?
I highly doubt it. Usually you only use allocator when you need to change the standard C way of allocating memory. I don't see any class in this major where you need to do that, and only specialized projects need that. That's why there's a default. But it's available because it's C++, and C++ wants you to be able to do anything you want. Of course.
Did it help me win the lottery?
I'm sure he wants you to do that.
That'd be awesome.
Good luck. I'm sure Strustrup would love to help you win the lottery. Okay, so let's go look at a list. Hey, it has, we haven't talked about iterators yet, so we're going to ignore that. You can call a function, is it empty? Return how many elements are in it. I don't know what max size is. You can get the element in the front and the element in the back in the linked list. Hey, that front and back, what does that sound like from our previous lecture? I guess that was two lectures ago. Not quite.
I don't know what it's called.
That's what I was asking. What'd you call it?
It was the one where you push the front,
Mhm.
the node into the front. Is that what you're asking?
Yeah. What was that pointer?
The head and the tail.
There we go, the head and the tail. So previously we talked about the head and the tail pointer. This is just returning what's at the head and what's at the tail. Oh. Let's see. So we can access the front and the back of this. We can assign, we can push to the front, pop the front. We can push the back, pop the back. We don't care about C++ 11. We can insert somewhere in the middle. We can erase something. We can swap, resize it. Hey, we can remove elements. We could call .sort. Oh, wouldn't that be nice? But don't sort for stacks and queues. You don't do that. We could reverse it. Hey, look at all this nice functionality. Bet you'd like to have this for your previous lab, but don't do that because that's cheating. All right. So, what are we gonna do here? Let's go and implement a stack. There are no bugs, just random features. It's true. Although, what is random? Does randomness actually exist? Yes, of course. There is no other possible explanation. Wait a minute, how old were y'all when that happened?
Like 2 years ago.
2? Oh, okay. Oh, so y'all don't remember.
No.
Your,
Hey, the incoming freshmen don't know about it. They were born after. They don't know about it.
no, they were born after it?
Yeah.
Interesting. I was in college.
Just
Did I tell you?
imagine, like 2 years, all you're gonna have is people born afterward.
Oh, interesting. Did we have this conversation already? I can't remember.
I don't
No.
think so.
Good. Yeah, I just remember I was in college and we were studying rhetoric, and all of a sudden this guy runs in and goes, "People are bombing the trade towers." And I'm like, "What?" And the teacher's like, "Okay, well, I guess we'll go and watch that."
Because why not?
I guess. So yeah, we all went to the cafeteria and ate breakfast while watching. Wait a minute.
I
Yeah.
mean, it was early, wasn't it?
It was, yeah, it was early. Yep. Yep. Yeah, not good. Where are we? Class code. All right. so I'm going to copy template over. We'll call it to, we're on 9. 09-stack. 09-stack. Perfect. So let's go and create a stack.cpp. Oops, that's not what I want. If not, define stack underscore stack HPP. Let's go define it. All right, let's go create our stack class. Oh, this is not working out well. Let's try that again. All right, so what do we need to be able to do with the stack? We need to,
Be able to add to it.
let's add to it. All right, so we do that via pushing. So we're going to void push. We'll call it int val. Right now we'll just use integers. What else do we want to do? Remove. And that's done by popping, because we can only remove from the end. We can only push to the end and pop from the end. So void pop. We want to be able to peek. Peep. Peek. And anything else we want to do?
Don't we need to put something in the void pop so it knows where to pop off? Or is
You're
it-
always popping from the end.
Okay.
Yeah, so you always pop from the end on a stack.
But you're
it's-
not deallocating it when it's popped off though, right?
Yes, you are. Well, maybe.
Because you were on the board.
Well, that's because I was using an array. But if we use a linked list, then it's automatically deallocated.
Okay. So it makes more sense.
It's magic. Magic. We do need one more. Anyone take a guess? Welcome back. Oh, if I do one more letter, it's going to give it away.
Size.
There, yes. All right, and I think that's really it. We could have more if you want to, but nah. Let's see, source stack.cpp. Oh, I called it CPP. Ooh, that's not good. Let me fix that. This should be an HPP file, not a CPP file. All right, good. Whew. Much better. All right, so let's go clean this up. I forgot to put in my new line. And then we need to what? Include stack.hpp. And we'll go over here. I did not mean to do that. We'll do stack : boom, boom, boom. All right. Hey, let's make sure this compiles. Oh, it doesn't like the fact that we're returning a non-void. So we'll always say that the size is 0 and the top element is 0. Perfect. Okay. So let's, ooh, someone joined, thanks. So let's start using our testing framework. Call it the stack test. We'll call it the stack. Yeah, it's just gonna be the stack test. All right, so we want to be able to create a test. So we want to create a stack, and probably, what do we want to do? Push, let's push the number 4. And then, what, peak? All right, so we want to stack.peak, that should equal what, 4? So we'll do a ts assert. All right, and then we'll do make stack test. Ooh, not declared. Probably should include it.
That'd be a good idea.
Ah, details, details, details. Text said failed. Assertion failed. Peak equal 4. Huh, that didn't work. So we need to make that work, right? Let's go make that work. All right. So I'm going to help you out here. And the first thing we want to do is, y'all said you wanted to use a linked list, right? So we'll use a linked list, but we're going to use the STL as a linked list because there's no need to reinvent the wheel. Now, if y'all want to include your old linked list code into this code that might possibly be error prone and totally fail the autograder, that's perfectly fine. But the STL has been tested, so it's up to you which one you trust more.
Sounds weird you say it's been tested like that.
It's
Sounds
never
almost like a
tested, though.
disease.
It has been tested. Well, I mean, what do we put in front of everything inside the STL? We do STD, right?
Yeah.
I did not make this up. This is what they do. I did not make that
Our
up.
program's full of STDs.
Yes, we got STDs all up in our program. These terrible jokes never end. All right, so we have a list. What should we make it a list of?
Objects.
Let's not do that.
There's no objects. There's no, well, of what type of object?
We were talking about plates earlier.
Integer, so that's the primitive. What?
No, never mind.
Well, what is our stack made of?
Nodes. No,
What?
no.
What does our stack contain?
A list.
It's a list of
Nodes.
numbers. What are we pushing?
Numbers.
Integers. Hold on. I'm sorry. I think I understand what the problem is. We need more precision. There is no number in C++. You have byte, or actually, I'm sorry, character, unsigned character, short, unsigned short, int, unsigned int, long, unsigned long, 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 unsigned long, long, float, and double. Yes. So we have 12. Yes. I didn't make this up. I just work with the system. You understand architecture why that's the case. So we want to make them of integers. Let's just do that. Oh, someone typed in. Thank you, whoever did that. What should we call this thing? Yeah, y'all should start typing. I've been typing too much. What is this list going to represent? The stack, sure. Then call it stack. Nums. Let's call it stack. All right, perfect. All right, let's save. Make sure that compiles. All right, good. Still fails. All right.
Cool.
Sweet. All right, so we need to be able to push. So let's go look. Y'all can type while I'm up here, by the way. So we have these functions up here. Which one do you think we should use?
Push back.
Okay, we could do push back. Add an element at the end. All right. Adds a new element to the end of the list container after its current last element. The content of val is copied or moved to the new element. This effectively increases the container size by 1. All right, did someone type that for me? But what are we calling that function on? We only have one variable. No. We've already declared its STD-ness. It's just called stack. Yeah, there we go. Push. Back. Oh. All right. Let's go see if that works. Okay, it compiled. So the other one was peak, right? So what do we want to do here?
We want to look at the
All right. So I'm going to click on this one. Back returns a reference to the last element in the list. And reference, that's going to be the last element. So yeah, that's going to be the last element. Whoa, 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 whoa. You had it right and then you killed it?
No, just return it.
Yeah. Oh, I see. Okay.
Let's go.
All right. Let's see how that works out. Huh, it passed. How about that?
Is it not supposed to?
No, it was supposed to.
Making everybody nervous.
I like to do that. So what should this be? Wait. So I just answered it. All right, let's go. Let's run it. Yeah. Hey, that worked. Great. Oops, that's not what I meant. Then what should peak be? All right. Oh no, we failed.
We didn't write pop yet.
Oh, we didn't write pop. Silly us. All right, what do we do?
Pop back.
Pop back. Removes the last element in the list container, effectively reducing the container size by 1. Notice that this is a void, so it doesn't return anything. All right. Okay. Hey, we're doing great.
We're just the best.
We are the
We're
best.
at this. There's no one better.
Right? So, yeah, let's do this. This is a good one. Is that right? So every time I push, I'm going to call peak and make sure it's still there. You know, just throw up everything. Let's see if that works.
Yeah, but what about all the stuff after it?
We don't care. Because it's peaking right after it puts it on there, and then after here, we continue on. All right. Now we need to test the size function. So let's go do that. What should the size be at this point? 2. Oh no, we failed. We broke it. Huh. Hey guys, let's see what we can do. Notice I'm not using the stack or queue inside the STL, which does exist, by the way. I'm using the linked list. Actually, is it on here? Oh, it is.
Size.
Whoa. Whoa. All right. Return the number of elements in the list container. Oh, okay, look at that. All right. We should write more tests, but nah, I'm not going to right now.
It works.
It works right now. All right. So how difficult did that look?
Not too bad.
Not too bad. Not all these labs are going to be super difficult. Some of these, if you just think about it, are going to be pretty quick. Work smarter, not harder. I tell people, use this, tell students, and then all of a sudden they're implementing an array inside their stat class, trying to account for every little corner case. That's fine. Don't do that. All right, so we talked about stack, pushing. Oh, that's great, popping. bold. All right, copy, overloading, that's nice, blah, blah, blah. Using linked list. Oh, so let's go draw the linked list implementation on the board because it is important to actually follow this. So I was using imhead, it currently goes to null. When we go right here, what do we do? We put for, yeah, how are we going to put for, okay, I'm sorry. We're implementing a stack via a linked list. So we're going to push for, what's the first thing we do? Create a node, thank you. Hey, it's going to be a doubly linked list. And what's previous pointing to? And what's the next pointing to? No. All right, let's push 15. What do we do? Create a node. Pretty much, guys, whenever we use something that's not an array, and I say, what's the first thing we do? About 9 times out of 10, the answer is create a node. All right? All right.
So everything involves nodes.
Nodes, yes.
Everything
Unless it's an
pointers.
array.
Yeah.
Then you
Nodes
just,
and pointers.
yeah, nodes and,
Other
yeah.
nodes.
Now you know why pointers are so important. It's going to be pointers all the way out. All right. So, now what do we do?
Do we make the 4, the right side, point to the left side of the 15 on there?
We could do that.
Or,
And that's not a bad idea. The only issue is once you do that, you're going to have to keep track of the tail for popping. So let's do it the other way, which is make the 15 next point to the 4, and that way the previous point to the 15, make this point to null, and then have mhead point down here. So we just put it in the front.
okay.
Okay? Pushing a 1, what's the first thing we do?
Create a node.
Create a node, all right. And then its next is pointing to 15. So 15's previous is pointing to 1. Its previous 1's is null. And that points to 1. Perfect. Let's do it again. Push -3. What's the first thing we do? Create a node. Its next is pointing to 1. And 1's previous is pointing to 3. And -3's previous is pointing to no. And then what's the last thing we have to do? Update imhead. Notice I haven't created a tail. 1's actually not needed. All right, when we pop, what do we do? So we take out the -3. What do we do with mhead?
Points to 1.
Points to 1. Do we do anything else?
Make the 1 the previous null.
No, there you go. Don't forget that. Otherwise, you're going to have a dangling pointer. All right, let's do one more. Pushing the 12. What do we do? Create a node. Yep. Add node. Create a node. Its next is
1,
pointing to 1. 1's previous is
12,
12, and 12's previous is
null,
null. Anything else?
M.
Input. All right. How we do it? I drew it like this, so it's very obvious that it's kind of doing this. Move back up. Excuse me. But in memory, it might be jumping all around. Okay. Great. Let's stop for a moment.